I'm putting together this Austro Daimler as part of an upcoming video. A big part of this project is to try and keep the weight as low as possible. To keep it affordable though, I am buying modestly priced bike parts and I'm machining off the extra weight. In today's video, we're going to machine this 100mm expansion plug. We're going to see just how much weight we can remove. So if you're interested in chasing down marginal gains with me, let's get started. Oh, and I've got a cold. So when you notice my voice sounds way off from normal, I'm not an AI bot or anything like that. I've just got a chest cold. So let's see what this whole thing weighs before we start. We are looking at 85 grams. So that is with the top cap and the preload bolt. And what do each of these components weigh? Geesh. Top cap and preload bolt weigh 15 grams. And then the central bolt, the adjusting bolt weighs 10 grams. The top and bottom washers, what do they weigh? Oh, I can't get this one out. Come on. All right, there we go. All right, so the cones, 18 grams. And then the knurled aluminum, 44 grams. So of the 80 whatever grams, half of it is in this knurled aluminum. This is the part that grabs the inside of the steerer. I think we've got a lot of opportunity here to remove material. So these are the parts I removed from the expander plug that I think we can actually do something with. So let's start with the preload bolt. This is too long by about twice. So I'm going to cut off about half of it, half its length. That'll save us some material. The way I cut down a bolt like this is I just use a hacksaw. I thread the bolt into a nut and I clamp that nut in the vise. When the vise is tightened down, it squishes that just a little bit and it holds it firmly in place. The edge of the nut also makes a good surface for the blade to write against, so I get a relatively clean, relatively square cut. The top cap has got a nice dome to it. It looks really nice, but that dome has got a lot of extra material. So I'm going to use the lathe here and I'm just going to cut this down until it's flat. We've got these cones, and what's important here is this conical surface. So when this is tightened down, it's what forces this outward and causes it to expand. So we don't want to mess with that surface or that one. This is the upper adjustable cone. This is the part that sits against the top of the steerer. It's got this ridge all the way around that's not doing anything. It doesn't need to be there. So I am going to take the lathe and I'm just going to turn that off of there. Probably won't save much, but you know, every gram helps. This one, it's not particularly thick, but I think there's enough material here that I can put this in the lathe and maybe take a millimeter or so off of this surface. It'll get us a little weight. And then these guys are the heaviest, these three. So I think removing material here is probably the best bet. So I'm going to put these in the mill and then I'm going to use a ball end mill and I'm just going to cut out as much material as I think I can get away with here. I'm using a 1/4 inch ball end mill. I've got it chucked up here in the mill and then I've clamped that long piece of knurled aluminum in the vise. I oriented it this way because I'm going to use my power feed. That way I get a nice, consistent, smooth finish. And then last is this piece, and it's actually heavier than you would think. I don't think we need all these threads, so I may be able to put this in the lathe and just take maybe a millimeter or so off of about half of it. We really only need the part that engages the threads in the aluminum. And when this is installed and tightened down, there's a lot of unused threads up here. So I've got that threaded steel piece in the lathe, and I'm just going to turn down the top 6 millimeters, quarter inch or so, and remove the threads and a little bit of this top shoulder. It's not going to be a lot of savings, but it's going to be better than nothing. I got to be real careful because I'm working right up against the chuck. You can see how little clearance I have, and I don't want to run that into the chuck, so we'll be extra careful. Here's a look at all the modifications I did. So starting with the top cap, I removed material from the upper surface, and I cut a chamfer so that a conical head bolt will fit in. I took the conical head bolt and I cut it down to the right length for the bike I'm using. I turned off about half a millimeter, maybe a bit more, from the outer diameter of this lower adjusting cone. I removed material from the upper surface of the upper adjusting cone. And then I turned off the shoulder and some threads on the main steel bolt. And on the knurled aluminum pieces, I cut a groove here to remove material from the inside. And then I cut off the corners, so I removed some excess material where each one of the pieces butts up. And then I'm replacing the steel springs with some rubber O-rings. It occurs to me I should reweigh the assembled product so you guys can see the end result. So it now comes in at 63 grams. Keep in mind that this is the 100 millimeter version of the expansion plug. This is the longest one you can get, so it's also the heaviest. 63 grams is a pretty good final weight. So we saved what? I think it was 85 before. So is that 22 grams cut off the top of it? I'll calculate what percentage of weight savings that is and put it on the screen. A 26% reduction in weight is really impressive. That is quite a bit better than I expected I was going to get when I started. I really enjoy doing this kind of thing. It's almost like a challenge, and I get a lot of satisfaction when it turns out really nice, when I do better than I think I will. If you've got the machine and you've got the necessary skill, buying these cheap bike parts and then cutting off that extra weight yourself, it's a lot of fun. So that's it for today's video. Until next time, I'll see you guys later.